Hey, my name is Austin Peacock, and today I want to talk about the longest TAC case that I ever worked, over 3.5 years. Let's get started. So I got this case about 6 months into my career. I was still pretty green, and it was actually a requeue from my buddy Chris, who was far ahead of me technically at the time, maybe still, and he went to college for computer networking. And so I was constantly learning stuff from him, and the case requeued after 3 months because it was taking too long, which is hilarious considering how long it took. I thought it was really funny that I was gonna get this case and solve it, be really competitive about it, and rub in his face. So I picked it up and started working it. So the problem description was deceptively simple. The only thing that was happening is that traffic would cease to traverse the port, and you had to shut and no shut to recover. It's something I'd never seen before, and honestly, I've never seen since. This was also on IE switches, which are industrial switches. So these are hardened for factory floors, environments that are outside, high humidity, high heat, low temperature. They get the job done, but they're also very, very simple devices. They don't have a ton of features, and we also didn't get a lot of cases on these. Normally when a case had been open for months or years, it's because the customer had hit a really corner case bug that wasn't affecting their network, and they were just waiting for the release to come out, test that it had fixed it, and close the case. A lot of customers were okay with just closing the case and you'd reopen it, but some customers have kind of been burned by that in the past, so we just keep it open and just keep updating it so it didn't close. That was not the case for this customer. He had over 100 of these IE switches, and it was happening virtually every single day. These were connected to power monitoring devices. So he would see them go offline, and then he would have to trace it out through the network and find the port and no shut it. Today, you could probably use something like Claude or ChatGPT to write a simple Python script, but he was not doing that. He was doing this manually for a long time. So the first thing I did was get this exact switch in Kalo. So if you're not aware, Kalo is the internal team that Cisco uses to build the recreates for TAC engineers. It's really powerful because you can just open a case, get the exact hardware and software, and they set everything up for you, and then just reach out to you when it's finished. So I got one of these switches and hooked up every single port, and then created a loop so I could just send thousands and thousands of packets a second, and just waited. Weeks went by, I would check every single day. Nothing ever broke. It was just rock solid. So I reached back out to the customer. I was like, hey, I've put this in my lab. It's not breaking. Would it be possible to send me the type of device that these switches are connected to? And he obliged. He was super accommodating. So we got this device in the lab, and it was just a very strange device. So it's super niche, and it monitored, I guess, the frequency and amplitude of these power cables that were connected into it. And the user interface was just abysmal. It had a very, very specific cable that I also had to reach back out to the customer and get. And this was back in 2012 when everything wasn't online. So there was no configuration guide or anything for this. I just had to figure it out. So I got that up, ran traffic to it. Weeks went by, nothing broke. So at this point, I reached back out to the customer and I was like, I want this exact setup. Please send me the exact power device, the exact switch that has already seen this issue happen, and even the exact Ethernet cable to connect them. So at this point, I had the exact hardware down to the Ethernet cable. The only thing that was different was the traffic itself. I was thinking maybe there's a certain type of packet that is intermittently seen on their network that's causing this lockup. So I asked the customer to run a span capture that ran 24/7 with a 24-hour loop. So that traffic would loop every 24 hours. And then once it broke, send me that traffic. So this was over 1.5 years at this point. And this capture took probably over a month to get because the ports themselves weren't flapping that frequently. It's just he had such a large number of devices, he was feeling that impact. So once I got it, I was like, this is it. This is the exact traffic, the exact devices. I'm going to do it. I'm going to recreate this issue. But still, it would not break. This was by far my oldest case at this point. And I remember thinking one day, like, I am just going to solve this. And I got off work at 6, went down to the lab, and I stayed past midnight. I tried everything under the sun. I was jiggling cables. I was hitting the power cable. I was trying to look for features in the power device. And it just rock solid. Like, it just would not break. It was just so frustrating. And nothing I did would work. Unfortunately, what happened was it sat for a long time. I was just too busy trying to learn NXOS, and I tried so many different things. Around this time, the team split, and it went iOS and NXOS. So this was an iOS case, but I just couldn't let it go. I didn't want to dump it on somebody else, and I just had to like see it through to the end. It's hard because the customer was so calm about it and accommodating. And the reality is, unfortunately, that the squeaky wheel gets the grease. And he just wasn't being very squeaky. So what ended up having to happen was I had to be that squeaky wheel. And eventually I just got in front of enough people and said, this is insane. This guy's affected daily by this bug, and reached out to the business units and reached out to the developers that own this stuff. And finally, I got it in front of someone that could actually help. So I got in touch with these two developers and got them completely up to speed, told them everything I tried, and they just didn't really have much to add, and they just decided, let's go on site and see if anything sticks out. So I didn't mention it before, but these switches were out in very rural Oklahoma. And these two guys, I believe, flew into Oklahoma City, and then they had a 2-hour drive out to the site where the customer was. And it's insane, but lo and behold, they hit a twister. And they said it actually passed in front of them on the road, and they had to seek cover underneath the bridge until it passed. So I almost sent these guys to their death to try to solve this case. That's how dedicated I am.
Some of you may die, but it's a sacrifice I am willing to make.
So after narrowly escaping the tornado, these guys finally got on site, and they took a bunch of pictures, sent it back to us, and this is what actually ended up solving the case. The problem was the customer was running unshielded Ethernet cables alongside the power cables that these devices were monitoring. So Ethernet cables work by sending electromagnetic pulses across devices, and the power cables themselves would also fluctuate. And it took just the right amount of fluctuation to mimic something that would lock up the port. And that's what was causing the issue. It was honestly a little bit of a letdown. I mean, it was good to finally solve it. I never really got the sense of accomplishment myself, but it's also something I took with me for the rest of my career, which is that some cases can't be solved with the information that you have. Inside of Cisco, you can look at the bug, and then they have a diff, so that's the changes that they made to fix everything. And I remember when this one finally got fixed, I looked at it, and it was the longest code change I've ever seen. It was over 3,000 lines. I think they just rewrote the port client or port manager or whatever it was. They got the code out there, he upgraded, he was good to go. We had actually had some beers that day that were in the office, so me and my buddy Chris got together and took a picture of ourselves and sent it to the customer and just thanked him for being patient, waiting 3.5 years to get this solved, and we told him it was the longest case we'd ever worked, and just cheers. It was cool. So if I could do a post-mortem on this is what people mean when they say you have to advocate for the customer. And I think I kind of fell flat there. He was being so nice and patient, but it was just unacceptable, really, how long he had to wait to get it fixed. And I should have really been pushing harder to get the developers involved and to get it fixed. Also, it's good to keep in mind that you can be as tenacious as you want to be, and you can work as hard as you want, but if you don't have those power cables running along the unshielded Ethernet, you're never going to recreate the issue in your lab. And there's a lot of issues that you work in your career that are like that. It's not like a test where there's a well-defined answer. It's just ambiguous, and sometimes you figure it out and sometimes you don't. But that's it. That's my longest ever TAC case. I'm Austin Peacock. If you want more networking stories like this, head over to good-gateway.com. Please like and subscribe, and I'll see you in the next one.